So folks, if you remember, in one of our earlier pre-works, we discussed the benefits of the various forms of a line. So for example, we've looked at the form ax plus by is equal to c. And we've also looked at the form y is equal to mx plus b. I know that sometimes students have a favorite form of the line. However, it is important that you learn all three. Each one has its own usefulness. And in this section, I want to focus on the point-slope form of the line, which looks like y minus y1 is equal to m times x minus x1. One of the things that students find confusing about this is there's all sorts of letters in this equation, and I just want to remind you that this is the y and this is the x that you're used to seeing, just as we see it in every single one of these forms. That's the x and the y. What often then causes some confusion for students is the presence of this x1 and this y1. And I want to tell you that the ordered pair x1, y1 is any fixed point on the line. So once I fix that point, I leave it alone. And, I don't know why that's open, sorry folks. And here we also have, in this form of a line, we have the value m, but that's just the same m that we've used here, which stands for the slope of the line. Okay? So this is the form that we want to focus on whenever we're building the equation of the line. In fact, let's go ahead and say that. The point-slope form, this format right here, the third one, which is usually students' least favorite form of the line to learn, it's useful for building the equation. Folks, I know that you may be very comfortable with the slope-intercept form. That's the y equals mx plus b form of the line. However, that will not be your go-to form of the line when you're in calculus. When you're in calculus, you will need to be accessing the point-slope form of the line. So you may be able to do a lot of the problems that you and I are looking at today using the second form. However, it is absolutely essential that you learn this third form of the line, this point-slope form. Let's go ahead and derive it here. Remember that we've always had the slope formula, m is equal to y2 minus y1 all over x2 minus x1. What we're going to do is we're going to allow the order pair x2 comma y2 to vary. And so that would give us the equation m is equal to y minus y1 all over x minus x1. What I can now do is I can now multiply that denominator over to the other side. So if I were to multiply that over to the other side, we would end up with y minus y1 is equal to m times x minus x1. And this is that keeper point-slope form of the line that I need you to know. Great. So let's go ahead and look at how to apply this new formula, the point-slope form of the line, to doing a problem like this. Now folks, in letter C here, I am absolutely confident that you have the ability to use the second form, the slope-intercept form of the line, but that's not what I'm trying to teach you in this section here. Okay? My goal is that you learn how to use this point-slope form of the line that we were just looking at. Let me clean that up just a little bit. My goal is that you learn how to use this point-slope form of the line. Okay? So we're going to go ahead and use y minus y1 is equal to m times x minus x1. And we're going to look at what we know. Well, we're going to use this as our x1, and this is our y1 because this is the fixed point on the line that we're given, and we'll use this to be m. And then simply plug those values in to the equation of a line. So if I do so, we end up with y minus negative 4 is equal to minus 1/2 times x minus 3. Or if you want, you could clean it up. You could clean it up as y plus 4 is equal to minus 1/2 times x plus 3. Now folks, just to convince you of the importance of this form of the line, in these problems here, for the majority of them, I'm asking you to leave your answer in this point-slope form. I know that in previous classes, you've been asked to always put your answer into slope-intercept form. However, I'm trying to make sure that you learn this particular point-slope form of the line, and I know that if I say leave your answer in point-slope form, you may not use the method that I'm teaching you. Okay? So it's very important to me that you work these next few problems exactly like one we did above here, where here I give you the ordered pair, -3, -2, and I give you the slope, -4/3. And I'm asking you to leave your answer in point slope form. So go ahead and give that a shot. And then I'd like you to also try questions 3, 4, and 5. The solutions will be available for you. Let me know if you have any questions. Okay, so folks, as a reminder, just to kind of recap this, I know that these my underlining gets a little messy. I apologize for that. That happens when I don't have full mouse capability. Let me just fix this up. So we've got these 3 different forms of a line. Okay? Each one of them has a special use. We saw that this was very handy for graphing. We saw that this was very handy for also for graphing. This one was also for finding the x and y intercepts. But this one, this third form of the line, I need you to know that this point slope form of the line is useful for building the equation. And that's the big takeaway in this class and in your calculus classes. Whenever you're asked to build the equation of a line, you want to be using this third form right here. Thank you, folks, and I'll see you in the next video. You are going to go ahead and finish these remaining problems. Some of them will have hyperlinked solutions to them. Thank you very much.